Let's solve some questions regarding fundamental theorem of arithmetics. I take this question from our book, that is R.D. Sharma, the example number 6. That is a very beautiful question. It says that we want to prove every positive integer different from 1, that is a positive integer, if n is a positive integer belonging to positive integer and is greater than 1. Okay, means different from 1 is greater than 1, is not an equal to 1, so different from 1 can be expressed as a product of non-negative power of 2. Non-negative means, for example, if A is a set where we say 1, 2 and B is a set, say minus 1, minus 2 up to this, and suppose C is a set of 0. So this is a negative set, this is a positive set, is a 0 set. So non-negative means we add 1 plus C because it is a non-negative where the negative part is not. So in that case we also, non-negative means including 0 and 1, 2, that is our whole number. Okay, so non-negative power and odd number. So we want to prove that if n is a positive integer, it is expressed as 2 to the power k, where k is a non-negative integer, and m, where m is a odd number. So we want to prove this thing. Okay, so how we solve this? Let's begin. So say solution. We want to prove that n is equal to 2 to the power k and to m, where m and k and non-negative integer, m is a odd number. Okay, now using fundamental theorem of arithmetic, so use of fundamental theorem of arithmetic. Okay, so we know that according to fundamental theorem of arithmetic, I always say FTA, that is every composite number is expressed in prime factors in ascending power of it. Okay, now so that is it is our n. It is easily expressed as P1 is prime factor into the power some k, say to the power some k, k1, so for example, into P2 power of k2 and P3 k3 and up to P, suppose say z power k. Okay, what I am saying that every positive integer, the power means, for example, we say n is the power of p to the power k to the power k. It means that if k is equal to 1, in that case n is a factor of p1. Okay, for p2 again p1. If we have k2, then say p1. If for example p1 k1 and p2 k2, for example a factor of n, so in that case if k1 is equal to 1 and k2 is equal to 2, in that case p1 1 and p2 2 and factors. For example, say 4 2 to the power 2 into 1, the prime factors. So this is an example of it. So this is not in factor prime, so this is 2 into 2, this is not. So this is an example of 2 to the power 2. That's an example of it, that is every composite number in this. So now again n is this, so so here it is only 2 case. So we express the factors in the product of, it's a prime number in the ascending power where p1 is less than p2 less than p3 up to this. Okay, so case 1 and we have case number 2. Okay, so first case says that suppose when we talk about a prime number, okay, once again, when we talk about a prime number, it means that we talk about 2, we talk about 3, we talk about 4, 5, we talk about 7, then 11, this. So in that case 2, first to talk about even. So when we talk about even, it means 2n multiple, and odd means which not divisible by 2, that is 2n plus of 1 or minus of 1. So in that case this is the prime number. Okay, so the prime number 2 is the only even number and remaining all are odd. So every prime number is a fact. It's two types. First, single is only one element, which is 2 is even, and another element is odd. So here so our first power is, that is p1 is equal to 2, and remaining factors are odd. Okay, odd number. Once again, sorry for that, I adjust my stand. Okay, so remaining factors are 2, odd number. And now we case 2, that all the factors are odd. That was again case, that is in that our factor that 2 is not included, or all factors are odd. For example, say like an example of when we say 9. Okay, like a 9 is a composite number and its factor is 3 into 3, and here is not 2. So like an example of it, that is our n is an integer, its all factors are odd numbers, no even factors, odd numbers. Okay, so let's take case 1. First we take case 1. So when we take case 1, so our n, which is factors are p1 k into p2 k2 and up to pz and k okay, z for example. So in that case, so our n is an integer, so p1 is 2, so 2 to the power k into p2 k2 up to pz and kz. Okay, so now this is an even, because k is a non-negative integer and upon 2 is even, you know, that is 2 into 2. This is an example of 2 to the power 2. This is an example of, this is a non-negative integer and this is a prime factor of 2, and is 2 is a power of according to FTA, and it is right. So now this 2 to the power is an our factor, that is non-negative power of 2, that is 2 to the power k is, we say that is a non-negative power of 2. Okay, and remaining all are odds, as we mentioned our case, the all remaining factors are odds. So now say this is an m, so now our n is a factor of 2 to the power k into m. So we prove that this is a factor of this, hence proved. So now let's take case 2. Okay, it's time for case 2. When we talk about a case 2, it says this all remaining factors, all factors are odd number, that is all factors are odd number. So now so n factors are p1 k, p2 k, 2 k1 up to pz kz. So our n is 2 to the power 0, because k is stamp 0, and p2 k2 up to pz kz. So now n become p2 k2 up to pz kz in into 2 to the power 0. So in all, 0 is a non-negative. Okay, when we talk about non-negative, I also explain why we add as where we talk about yeah, this is okay. So in that case so our n is again, this is a 2 to the power some non-negative, that is again non-negative power non-negative power of 2, and is our odd number, say m. So again in here case, n is a factor of 2 to the power k into m, and now this equation 2 and equation 1. So we say from case 1 and case 2, or simply equation 1 equation 2, that the number n, which is positive, is expressed as the non-negative negative power of 2 and odd number as product. I hope you understand what I am saying. If you understand, I gave you some example of it, so you understand the beautiful work of fundamental theorem of arithmetics. And now please, if you understand, like and subscribe. Again summarize the concept. Let's we first take two cases. First take as in if 2 and then if all factors are odd number, when solving we get the overall value. And I gave you some example of it. First example is our daily question, that is your own thinking question. Build your own thinking, that okay. And second question I gave you the exercise number 1.1, question 3 to 5. If possible, please do this question. So these are some homework for you. I hope you understand. If you understand, like and subscribe. We will meet next video. Bye bye. Hit the like button. Okay.